right. Okay, lesson 2, operations with polynomials. So sometimes we might be asked to simplify polynomials. What that means is we want to combine like terms together. So like terms are terms that contain the same variable raised to the same exponent. So it has to be identical. So for example, if we look here, we have 5x squared y and 3x squared y. They both have a part that is x squared y with no other variables. All they have is a different coefficient. So we can collect those like terms, and what we do is we add and subtract those coefficients, right? So we collect those like terms only by adding and subtracting the coefficients, okay? The rest of it, the variable part, stays the same. It's like saying we have 5 oranges and -3 oranges. The oranges would be the variable. So they don't change. So we're still talking about how many oranges we have, but we have 5 and we take away 3 of them. So we have 2 left, right? So in this case, that would mean that 5x squared y and -3x squared y would be equal to 2x squared y. So what we can notice from that is this part stays the same, and the coefficient is what we change, okay? So there we see that example right there. So we're going to simplify the following expressions by collecting like terms. And it's, for the sake of this, I'm going to highlight the ones that are the same. So I've got an M, an M, an M, and an M. So that means I'm collecting all these M's. So I would go 4 minus 12 minus 2 plus 1. There's an invisible 1 there. So if I add and subtract those, I get -9m, okay? Because 4 minus 12 minus 2 plus 1 equals -9, okay? So that's the coefficients. Okay, so sometimes it's more complicated and we have different terms. So here we have a squared b, here I have a squared b, and there I have ab squared, so that's not the same. Here I've got a squared b cubed. This is the same, a squared b cubed. It doesn't matter the order. Usually we would put the a first, but they are the same variables, so we can sort them together. And then ab squared is on its own, okay? So note that this is the same as minus 2a squared b cubed, okay? So let's take a look. Sometimes it's good to put them together. So minus 5a squared b and plus 3a squared b would be the first 2 there. Then I have -4a squared b cubed, and I'm going to use the rearranged version here, a squared b cubed minus 2. And then my last one, plus 6ab squared. Okay, now I've done it in color coding so that you could see what you have. So here, -5 and a +3, I have -2a squared b. Then I have -4 minus 2, so that's -6a squared b cubed. And then I have my plus 6ab squared. I've only done the colors there just to kind of sort out what's what. Okay, alrighty. Now, we also need to remember the distributive property. The distributive property says that if we have a minus sign or something or a factor outside of brackets, we need to make sure that everything in the brackets is affected by that. This is like having a -1 there. So we have to times everything by that. So the first thing we're going to do is we're going to get rid of the brackets by doing that. So here we'll have 2x minus 5z plus y. Then negative 1 times 7x is negative 7x. Negative 1 times 4y is negative 4y. And negative 1 times 2z is plus 2z. Okay, now let's highlight our variables. I have an x here and an x there. I have a z here and a z there. And I have a y here and a y there. Okay, we can group them or we can just combine them. Okay, so let's try by just combining them. So 2x minus 7x. So that would be minus 5x, right? And actually, I'm going to do it in red so it matches the highlighted color. Okay, so bear with me. So that would be minus 5x, right? Then the next thing I have is z's. So I have negative 5z and plus 2z, so negative 3z, right? And now I have my y's, and I'm going to leave them in blue because yellow is hard to see. I have 1 there and negative 3 there, so negative 4 there, so negative 3y. Now, once we get that they're all different variables, I can't simplify it any further. I can't mash them together. That would be my final answer. So that would be the completed answer, just like this would be the completed answer here. Okay, you can only add and subtract them if they have exactly the same variables. So here, let's do some highlighting. I don't have to do any distributing. So I have an x squared, I have a 4x squared, and then I have an x and an x, and then I have two, they're constants, right? Okay, so I have this equals x squared plus 4x, that would be 5x squareds, right? And then I have 3x plus 3x, so that's 6x. And then I have negative 5 and positive 5. So that's actually 0, right? We can write plus 0, but normally we would just write 5x squared plus 6x. We're lazy mathematicians, so we're not going to write that 0 down. Very colorful today. All right. Now, this is why I reviewed exponent laws yesterday with you guys, is because now we're going to talk about multiplying. And I talked about the distributive property briefly when we talked about that negative sign. The distributive property, I call it the trick-or-treating property. What it means is that if you go to a block and you're trick-or-treating, you want to make sure you hit all the houses. Same thing when we're multiplying and expanding polynomials. If I have a factor, or when an expression is being multiplied by a term, the distributive property makes sure that you are distributing that multiplication to everything within a brackets, okay? So for example, I have 4x minus 2 in brackets here, and it's multiplied by negative 5x. Now, there's variables. If it were numbers, we would just simplify in the brackets first and then multiply, but we can't do that. So we have to be able to distribute. So what we do is we multiply, each term by the numbers outside the brackets. Same thing here, 2x squared. Everything in the brackets, we have to make sure we multiply by it. So I call it my Halloween or trick-or-treating property because when you hit a good block, you want to make sure you hit every house. So you got to treat everything like a house that you're going to go hit. So this person's dressed up like negative 5x. He's going to make sure he goes to house 4x and goes to house negative 2. The general algebra for it looks something like this. And we can see how it works with these examples. So basically, we've multiplied everything inside by this. 5 times x is 5x, and 5 times 3 is 15. Same thing works when we're subtracting. 2 times 5a is 10a. 2 times negative 4c is negative 8c, or minus 8c. Now, when you're multiplying terms, the coefficients are multiplied and the exponents of the same variable are added. Okay, that is our exponent laws, right, from yesterday. So that's the multiplication law, right? Okay, so let's take a look. Simplify and evaluate if necessary. So we have the same base here, which is 2. We're multiplying, so we add those exponents. So this will be 2 to the 2 plus 3, or 2 to the 5. Okay? Now we can expand that further. 2 to the 5 is equal to 32. Evaluate if necessary. If there's variables, we can't really evaluate, but we can if there are just constant terms. So here I have an x times an x3, so that'll be x to the 4, and a y3 times a y. Remember, if there's no exponent, there's a little invisible 1 there, so it would be y to the 4. Okay, here a to the 5 times a, there's an invisible 1 there, so that'd be a to the 6, and b to the 3 times b to the negative 7, so that would be b to the negative 4. Okay, and we're just going to leave it with a negative exponent for now, because I'm not sure how far this is going. Okay, y to the 3 times y z to the 2, there's an invisible 1 on the y. We add those exponents. Z2, there's no z over there, so we don't have to worry about it. Y to the 3 times z to the 2, we can just write them next to each other. Okay? We can also expand and simplify using our distributive property. Right? Okay, so we're going to distribute this into, we're going to distribute this into the brackets. So 3x times x is 3x squared, and 3x times 2 is 6x. And that's it. We can't combine. There's no like terms, so we're good to go. Okay? Similarly here, it's just as we do each separate multiplication, we're going to apply our rules. So 3x squared times 2x is 6x to the 3, because there's an invisible 1 on that x. And 3x squared times 2 is 6x squared. Okay? Doesn't matter how many terms are in the brackets, we still distribute. Okay? Now, we may want to, well, let's do the distribution first, and then I'll talk about rearranging, because we always want to have our polynomials in the correct form. So negative 3z cubed times negative 2z is 6z to the 4, because there's an invisible 1 there. And negative 3 times z cubed times 3z squared, I'm going to change this because it's a negative, right? So minus 9z to the 5. And then negative 3z cubed times negative 1 will be positive 3z cubed, right? Now, they're not in the right order, so we do want to rearrange, because we always want to go from the highest to the lowest, right? So this will be negative 9z5 plus 6z4 plus 3z3. And that would be the correct answer. Okay? Put it in that correct answer form. Sometimes when we expand, we might get to simplify, right? But here we've got a subtraction, and then we've got a bracket. We want to make sure we use BEDMAS, so we're going to multiply first, right? So this will be 5x minus 2x minus 8. Now, look here, we have some like terms. So we're going to simplify by combining those like terms. So 5x minus 2x is going to be 3x minus 8. We always want to get it to the simplest form, okay? All righty. Another distribution here. Now there's 2 of them, so we're going to distribute there and then distribute there. Let's make it bigger so we can see it. So negative 4x times x is negative 4x squared. Negative 4 times 1 is negative 4x, or negative 4x times 1, sorry. Negative 9 times x is negative 9x. And negative 9 times 4 is positive, it's minus 4, so positive 36. And then we have our plus 1 at the end. Now let's simplify, right? We want to simplify by combining the like terms. I have an x squared there. It's the only one. And then I have an x and an x. So I can combine those. And then I also have these two constants. So we always want to make sure that we can simplify, right? So negative 4x squared, it's the only one. But I have negative 4x and negative 9, so that's negative 13x. And then I have 36 and 1, so plus 37. And that would be my simplified expression. Okay? Here, I would actually simplify first, because look in the brackets. I have an x and an x. So before I multiply, I'm going to simplify those first, right? And then I'll distribute. So x minus 5x is minus 4x plus 4. And now I am going to distribute that multiplication of that 2. So when I do that, I get 2 times negative 4 is negative 8x, and 2 times positive 4 is positive 8. Okay? Alrighty, if you want to pause, take a screenshot, just to get those examples. There you go. All right. Binomials by binomials, FOIL, and binomials by trinomial. Okay. We mostly just do binomials by binomials, okay, and I use the FOIL method. First, outer, inner, lasts. That's what FOIL stands for. So our firsts are A's times C, right? Our outer is A times D, our inner is B times C, and our last is B times D. So we have to do all of those multiplications when we are multiplying binomials. How does that look? Well, here's an example. 2x plus 3 times 5x minus 8. First, we'll do 2x times 5x, and we get 10x squared. Then we do the outer. Right? We did our first, now we're doing our outer. Our outer are the two outer terms, 2x times negative 8, which is 16x. Then we do our inner terms. Our inner terms are 3 and 5x. 3 times 5x is 15x. And then last, we do our two last terms in the brackets, 3 times negative 8, which is negative 24. So if we line that up, that's going to be 10x squared minus 16x plus 15x minus 24. We want to make sure that we simplify, so we have common terms of x, so we're going to do that to get our minus 16 plus 15 gives us minus x. Okay? FOIL is very, very, very useful, and we use it a lot. You'll use it in 10C, you'll use it in 20, you'll use it in 30, you'll use it forever. Okay? So let's practice. So we're going to do our first, outer, inner, last. So first is x times 5x, which is 5x squared, plus outer is x times negative 4, so negative 4x. And I'm just going to erase this for a second. Then next we do our inner, 5x times 1, which so it's plus 5x. And then our last, 1 times negative 4. We want to now combine our like terms, which are the x, and just telling you honestly, it's usually the two middle terms that you have to combine. Negative 4 and positive 5 will be positive 1x minus 4. And we get what's called a trinomial. Okay? Now at any point here where you think you got it, pause the video, try it, then press play and see if you got it right. Okay? So here, we've got x plus 6 times x minus 6. X times x first is x squared. Outer, negative 6 times x, so negative 6x. Inner, 6 plus, so 6 times x, which is plus 6x. And then minus 36, 6 times negative 6. We've got to combine our like terms, which are these middle terms. And let's see what happens. Wow, -6 and +6, that equals 0. So we're left with x squared minus 36. This is actually a special kind of trinomial. These are called conjugates because they are the same terms, but one is a negative sign and one is a positive sign. Okay? So they're conjugates. It's a special word, and we'll talk about that more later when we do factoring. All right, when you have a term out the front, what you're going to want to do is you're going to want to do your FOIL first. So FOIL first, and then distribute. FOIL first, distribute second. Keep your brackets. Okay? And some people will do it the other way. I don't. I do it this way. So 4x, then I'm going to have x times 3x is 3x squared. -2 times x is -2x. 2 times 3x is plus 6x. And 2 times -2 is -4. Okay? Combine your like terms. I have a -2x and a plus 6x, so I have a plus 4x. Minus 4, and now we're going to distribute, okay? Now, you can work left to right if you want to. This is just the way I like to, and you'll get the right answer regardless. So 4x times 3x squared is 12x to the 3. Remember, there's a little invisible 1 there. Plus 4x times 4x is 16x squared. And then minus 4x times -4 is -16x. Okay? And that's our final answer for that one. For D, now you can do it where you work left to right, so we can do it that way. You just have to make sure you keep your brackets. So you would go -5x minus 10 times -4x minus 7. So you see I keep the brackets, they don't go away. So we have to keep them in order to get the correct answer. Okay? If those brackets are there, they have to stay here. Alrighty, that's kind of why I like doing the foiling first and then doing it just because it's easier to remember to keep your brackets. But it still works. -5x times 4x, that's our first, is 20x squared. Outer, -5 times -7 is plus 35x. -10 times 4x, -4x is positive 40x. And then -10 times -7 is plus 70. We've got to combine our like terms. I've got an x and an x there. So I'm going to get 20x squared. 35 plus 40 is 75x plus 70. And there we go. Okay, a couple more here. 4x, so here the big thing is we now have trinomials. So with trinomials, you just have to make sure that you've multiplied everything by both terms. So there's the blue ones, and then there's the red ones. So I should expect after my first multiplication to have 6 terms. So doing the first using the blue, so I'm going to get x cubed minus 8x squared plus 10x. And then doing the red multiplications, minus 4x squared plus, 4 times 8 is 32. And then minus 4 times 10 is minus 40. Now, I still can collect my like terms. I only have 1x cubed, but look, I've got an... Oh, I don't want that. Sorry. Was 10 negative or positive? Positive, okay. So I've got x squared and x squared. And then I have x and x. So I'm going to combine those like terms. So only 1x cubed. I have negative 8x squared and negative 4x squared, so negative 12x squared. I have 10 and 32x's, so plus 42x's, and then minus 40. Okay, and that would be my final answer. Alrighty. Again, we're going to multiply the first term by everything in the brackets. So that's my blue multiplications, and then everything by the second term, which will be my red multiplications. So, blue ones. 2x times 3x squared is 6x cubed. 2x times negative x is negative 2x squared. 2x times negative 7 is negative 14x. Then I have 15x squared, 5 times 3x squared, and 5 times negative x is negative 5x, and then negative 35. Okay, now let's find our like terms. I have x squareds, and I have x's. Alrighty, so let's combine those. So I've got 6x cubed, negative 2x squared, and 15x squared, so I've got plus 13x squareds. Negative 14x and negative 5 is negative 19x, and then I have minus 35. So that would be the final thing there. Okay. Now, I'll talk a little bit about algebra tiles. This is another way to deal with multiplication, and I'm going to show you a system online that you can use called Mathies, and it will help you with algebra tiles. It's an area model, so it helps kind of outline exactly what we have. So for example, this is across the top, it's x plus 3, and across the side is x plus 2, right? So if we multiply them, it looks like so. We get a big block for the x squared, we get an x for the 1 times x's, 1 times x's, and then we have our 1's down here, 1's times 1's. So what we can see from it visually is that x plus 2 times x plus 3 is equal to x squared plus 5x plus 6. So we have to kind of break this down. So what are the factors representing the following tiles? Well, this would be an x, that would be an x, that would be an x. The big long ones are x's. This would be a 1. This would be an x, this would be a 1, 1, 1. So across the top, we have 3x plus 2. And down the side, we have x plus 3. So this is showing us the multiplication of 3x plus 2 times x plus 3. And if we add up what we have, well, this is x squared, right? These ones are x's. And these are 1's. Hope you can read all those. So I have 3x squareds. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I count that right? 11x. And then I have 6 there. Now, let's do it with a FOIL and just see if we get the same answer. So, using FOIL, 3x plus 2 times x plus 3. First, I would get 3x squared. Outer, I would get 9x. Inner, I would get 2x. And last, I would get 6. Now I've got to combine my like terms, those x's. So I would get 3x squared plus 11x plus 6. So yes, indeed, we do get the same answer. Okay, and like I said, I'll show you a system for algebra tiles that you can use online called Mathies, and it works really good for those of you who really like visual. We don't use algebra tiles past grade 9 or grade 10, sorry. But I know that there are some people that it's a really useful way for them to think about multiplying binomials.